Hi everyone, this is Niranjana Gayatri from the Department of Artificial Intelligence and Data Science. In this video, we are going to solve a sum which is based on a A-star search algorithm. Let us first see what is an A-star search algorithm. It is nothing but a searching algorithm that is used to find the shortest path between an initial and a final point. It is a handy algorithm that is often used for map traversal to find the shortest path to be taken. A star was initially designed as a graph traversal problem to help build a robot that can find its own course. It just remains a widely popular algorithm for graph traversal. Searches for the shortest path first, thus making it an optimal and complete algorithm. An optimal algorithm will find the least cost outcome for a problem, while a complete algorithm finds all the possible outcomes of a problem. The A-star search algorithm have various principles. Let me explain some of those. The first thing is a heuristic function. The A-star uses a heuristic function to estimate the cost of reaching the goal from a given node. The heuristic function is denoted by h of n for a node n and should be admissible and consistent. The second one is a cost function that is represented as g. The A star uses a cost function to determine the cost of reaching a node from the start node. The cost function is denoted by g of n for a node n and represents the actual cost of reaching node n from the start node. The third one is the total cost f. The A star combines the cost function g of n and the heuristic function h of n to estimate the total cost of reaching the goal node. From the start node, we are the node n. The total cost is denoted by f of n and is calculated by a general function f of n is equal to g of n plus h of n. The fourth one is a open set. The A star maintains an open set of nodes that have been discovered but not yet evaluated. Initially, this set contains only the start node. The first one is a closed set. The A star maintains a closed set of nodes that have already been evaluated. This set helps avoid revisiting the nodes that have already been proposed. Okay, now let us solve a problem to find the cost-effective path source node to a goal state node. From the given figure, the A represents the source node and the G represents the goal node. Okay. The numbers written on the edges represents the distance between the node G of n. The numbers written on the node represents the heuristic values h of n. The heuristic value estimates the cost from a node to the goal, while the path cost represents the actual cost from the start node to a given node. It represents a general function called f of x is equal to g of n plus h of n. Okay, let us compute the f of x for value for each of the terms. From A, we can reach B and E. So, let us consider a path from A to B, where f of x is equal to g of n plus h of n. Here, the g of n value is 2 and the h of n value is 6. So, we get f of x is equal to 8. Similarly, for the path A to E, we considered 3 as a g of n value and we consider 7 as the h of n value. So, if we sum it, the f of x will be 10. Here, the cost for the path A to B is less. So, moving forward by considering this, now from B, we can go to C and G also. So, we compute the f of x for both the values. The path A to B to C, which is equal to f of x equals to g of n plus h of n. Here, the g of n will be 2 plus 1 and the h of n will be 99. So, as in total, we get 1 or 2. Similarly, for the path A to B to G, 2 plus 9 as g of n and 0 as h of n value as in total we get 11. Here the path A to B to G has the least cost, but it is still more than the cost of A to E. Thus, we further explore this path. Now, from E, we can go to D. So we compute the f of x value for this, the path A to E to D. As mentioned earlier, f of x is equal to g of n plus h of n, 3 plus 6 as a g of n value and 1 as an h of n value, as in total, we get 10. Comparing the cost of A to E to D with all the paths we got so far, and as this cost is least, we move forward with this path. The next thing, the f of x for the children of D, A to E to G. So, as mentioned earlier, f of x is equal to g of n plus h of n as a general form. Here, 3 plus 6 plus 1 is a g of n value and 0 as an h of n value. So, if we sum, we get a value of 10. Now, comparing all the paths that lead us to the goal, we conclude that A to E to G, D to G is the most cost-effective path to get from A to G. I repeat, we conclude that A to E to D to G is the most cost-effective path to get from A to G. Okay. Now, there are various practical applications in an A-star search algorithm. Let me explain some of those applications. The first thing is terrain analysis and exploration of those. A-star can be used in terrain analysis to find the optimal path for exploring a region or analyzing geographical features. It can help in planning efficient routes for the exploration missions. The second one is air traffic management. A-star can be used in air traffic management systems to optimize flight paths, minimize fuel consumption, and avoid congested airspace. The ability to find the shortest path helps in efficient route planning for the aircraft. The third one is emergency response planning. Here, the A-star can be used in emergency response planning to optimize the deployment of resources, such as the ambulances, firefighters, and police vehicles. It helps in reaching emergency locations quickly and efficiently too. The fourth one is puzzle solving. A-star can be used to solve various puzzles, which includes 8 puzzles and 15 puzzles too. By finding the shortest sequence of moves to reach the goal state, its optimally guarantee ensures that the shortest solution is found. The fifth one is a well-known thing, a natural language processing. A-star can be used in natural language processing for tasks such as speech recognition and mission translation. It helps in finding the most likely sequence of words or phrases given a set of input data. And that's it for today. Thank you for watching.